Okay, all right. Well, everyone, thanks for coming. This is the last session of PyData 2022. So here in New York City. So thanks for hanging around, or else you didn't want to go outside to the rain. Either one. Thanks. So I want to talk about actually practical MLOps. It's a loaded word. We'll try to unbox it a bit and kind of talk about how I've actually approached the problem. So first, I want to walk through a traditional ML, kind of mainly highlight the issues. Anyone who's done actually ML in here probably knows those issues. So there'll be some actually resonating with you. I'll talk about a subset of MLOps that is actually what I think is important to address in moving ML to a production. And then I'll walk through a complete example. It's small, but it's kind of actually contrived, but it still touches all the points that I think are important in doing a production ML. So there are some files for this. If you wanted to download them, they're on my actually GitHub. Most laptops can't see this because it's actually, you don't have in the camera, but you can take a picture of this, for later. But this has the data set, which is actually small, but and some other things that are actually supporting this. And so my main goals are to basically I need to show to my unit managers the ROI for actually doing ML, right? And in doing that, getting a handle on how much time we spend doing experiments. You can't just go off, like you used to be able to do this. You go off for a month or two, and then you'd say, oh yeah, it's hard, right? But we've actually gone past that now. And other parts are getting a hold of the data source artifacts that you actually build and transform along the way. Model reproducibility, because sometimes you have to go back and build things again, change things, tune things. Once, way back, it was actually new, so you could kind of get away with things. Now, people have actually had models in production for years, and so you need to be able to have that continuity. And kind of a high-level thing, but basically getting timelines down for when you say, I'm going to do this in actually 2 months, getting some sort of way to manage that, make it easier so that you can actually predict things a little bit better. My ML requirements are a little bit different than probably everyone else here. I actually do ML-based technology for intrusion detection on aircraft and tanks and anything that moves, really. So my work is very embedded, and so I have once it ships, like it's actually shipped, it's gone. Like it may not come back for months actually, and so it's probably very different than what people usually do with actually ML models. They put it up in the cloud and they can change them really easily. So this has kind of changed how I actually work with it. And also a small team is me. I'm the only person that does ML in my company. So I am hiring too. And also, of course, open source, we all love it because I need the code. And so way back, this was all you ever did with actually unit ML. You basically get your data, build your model, and then you would throw it over the fence. Over the years, we've actually realized that it's probably the best idea. And so MLOps has come up as the ultimate answer for everything. And I won't be addressing all of the picture of MLOps, but nonetheless, ML, as you can see here, and probably know, it has its own actually set of unique challenges. So one of the biggest ones, actually, these are all about, I have 11 issues, and they're all about equally the same. And it's a very experiment-driven process, and so you have to basically iterate, and which is actually fine. I think that's fine, but it gets a little hard when you keep on doing iterations and keeping track of what step you're on, where you're at, what was the action you had prior run, all those things. They're fine when you're doing your graduate work, but when you have to actually ship things and people want to know where you're at with everything, it gets hard to manage if it's all written down. And so being able to keep track of where you are in the experimental data process is a problem. Reproducibility is probably one of the biggest ones. We've all seen these things where not just to actually ML, but it comes to highlight a lot in ML. When you have actually models that work well on your laptop, but then they don't work on someone else's actual machine, or when you ship it, it doesn't work the way you thought it did. So it gets kind of hard to manage, mainly because you have dependency problems and data problems and all these things kind of come in that make your life fun. Traceability, being able to basically, you have this a model that you come up with actually, and if it's great, fine. But what were the processes that you took it through? What was the parameters for tuning it? What actually were the data that you actually finally got after you went through it and managed it for a while? So all those things actually, it isn't just the end model, it's the whole entire chain that you want to have. And related to that, of course, is data versioning. You have this thing in the end that you ended up with that you trained your model on, but it wasn't what you were actually given or you took actually from the field. You usually have to take it and transform it, clean it up a bit, examine it. You figure out, like for what I do, I have tons of data in the petabytes, and I can't use all of it. So I have to take subsets of it, and I archive those things. But it gets real, it's hard, okay? Model versioning, this is fine when you have version 1.0 and you ship it. But once that ships, and then you have the 2.0, and you have something over here that uses actually 1.0, knowing how to go back and change model 1.0 can be challenging because the person who wrote that may be gone now. The data that you had was lost. That'd be bad, I think. But anyhow, there's all kinds of problems with getting the right actual model that you had and being able to you basically go back and figure out what was making up that. Oversight is kind of another facet. Usual software engineering, you have your team lead look at your code and say, what the hell are you doing here, or why aren't you using this this API or that? In ML, a lot of us are kind of left to our own. Even if we have our own groups, actually, you can kind of go off into the weeds, and so this makes it kind of, the culture isn't there actually first off, but having an easy way to come in and look at someone else's stuff is a necessary point, I think. And related to that is testing. We all love to test our code. My company is on this test-driven development thing now, which is kind of new. It's not really. It came back from it's actually back from the dead. It was back in 1996 it started, so old things are coming back. Artifacts. Related to the data earlier, this is more along the lines of not just data and the model, but all those pieces that come in between that if you're doing a complicated NLP model, you may have dictionaries of words that are actually good. You may have all these things along the way that are important in building the model, but they may not be the only things that you need, but they'll help you figure things out. And logging, this is not such a big thing, but usually, at least when you're doing it the first time, it's usually a manual process in building anything. And even the smallest things can be actually automated. But when they get more and more complicated, logging is it's not so easy to do when you have a lot of pieces that are actually moving around. Model refreshes. This is once you've actually deployed it, you have some issues with model you have where you want to get better accuracy in certain aspects. This gets a little tied to kind of going back and being able to pull out the tree of things that you actually did and do it again. And so if it's very manual, or if the person that was actually doing that before is now on a different project and you have to go and take it, and you have to go back and figure out what he or she did, and it's like a real pain to figure out like what were they actually doing here. That makes it really hard. And also in that point, it it makes it very hard for me as a manager to be able to have confidence that I have the same thing that was, I have the same type of coverage that we did before. And the final one is consistency. Like I said, if it's the first one, it's fine. When you have 10 of them and you have things that are shipping at different rates, some actually customers are more important, so you have to focus on them. But having project consistency is really core. And of course, the cookie cutter data science thing is really nice. Kedro, of course, is actually based on that tree of folder structures. So it's nice, but having that is really a very important thing. So signs that you may have some problems in your ML workflow, and these are just things that I've seen and things that I've actually done. Basically, you get long ramp-up times, so you get a new thing, and then all of a sudden you have to take a lot of time to figure out how to get going again. Technical debt, you have code over here. How do you share things that have been done before? Cannot easily reproduce models that you're asked to. And also scaling issues. And this is usually not technical-wise, people-wise. How to scale people. How can you use people more effectively? Especially when you have a tiny team, it gets kind of hard to be able to actually take on too much work if you have a lot of individual snowflake projects where you have to kind of do everything over again. So MLOps at the high level is probably one of the most overused terms we've ever had to actually encounter, and it still hasn't solved everything. In short, though, we're trying to basically take models from your laptop and put them into wherever you consider a production, right? And that part is what the MLOps is trying to solve, right? And the largest part of that is not getting it out there the first time. It's maintaining it 2 years later. That is when it's really hard because I don't remember things from my 6 weeks ago, let alone 2 years ago, what I did technically on a certain a project. And MLOps doesn't have to be so big and complicated and have to hire a team of people to manage your feature stores and your model observability, all those things. You don't have to have all those pieces, which is what I'm going to get to today. Like, these guys, Uber and Google and so on, they have a lot of things going on. They have people, they have teams that are dedicated to doing these kind of things. And but my point is, you don't even have that to get a lot of value out of this. So, kind of the components I see to MLOps, you have kind of this chain of things from data ingestion, pipelines. This is what I call the happy spot. This is where we all like to be because it's all things that we kind of know. Do data analysis and modeling. And then outside here we get to model registry, which is kind of like, whatever. You just talk to a fence. There's not a problem there. A deployment, same thing. And monitoring, I don't know anyone really that monitors their own models, but that's a thing too. And today, though, I'm not going to talk about all these things. I'm going to talk about kind of the core thing here. The data ingestion part is data sets like CSV files, JSON files. I deal with tons of blobs of data coming from actual vehicles. The cool part here is basically a bunch of Python code, and that's done with Kedro. And file registry, I use MLflow. It's a very simple thing to do. I'm not about that today, but it's a very important part that is simple to actually address, I think. And deployment is actually kind of, I kind of just off. And the monitoring is actually, it's embedded. So talking about Kedro, it's an open source framework. It's been around for a bit. It's really defined by a bunch of nodes and pipelines. And those nodes are what do the work, and pipelines are what you chain those nodes together to actually do larger pieces of effort. And so the sequencing part is cool. So here, we're going to talk about the work we're going to do is actually an anomaly detection. And I have a temperature data set right there. And we're going to build an isolation forest as our core machine learning model. And who in here wants to go along with this, or who wants to just actually watch? I don't know how much work needs to be done. Okay, good. So let's get ready then. So I don't know who likes PyENV versus Anaconda, but let's first actually create a new environment. And if anyone needs any help, actually, I'll be happy to help. Just yell. Let's make this as interactive as possible so everyone kind of get this, because this is not a very complicated thing, and I want everyone to understand that MLOps and all these things I'm talking about don't have to be really hard to get into. It is a bit kind of some things to learn, and there's a lot of boilerplate things, but in the end, I think this is really a good example to actually get your head into. And then the packages we use, or I use virtual environments, and Kedro is the only packages you need really to get things going. Obviously, ML work requires actually some NumPy and pandas, and obviously scikit-learn. And this is where, like every project that I start, I don't usually start here. This is actually kind of a cheat, but I usually tweak around for a little bit, and then I go like this once I figured out what I want to do. But this is where I would then start using Git right from the actual beginning. So the repo, everything is basically actually versioned, because all of the things that you're going to have, those artifacts are going to be part of Kedro, or in this basically tree down. Okay. Anything but 2, 7. Anything, any works. I've used 3.7, I think was the lowest I've used for actually Kedro. And so, and for this, once you have this going, Kedro new is how everything starts. And that's where you just type in a name. That's all you do. And then after that, you're done. I'm joking. So Kedro new, actually, let's just show you here. This looks actually. Can everyone see this? I'm increasing, yeah. So when you do Kedro new and you give it a name, it puts a whole bunch of junk in the configuration that has like a name and all those things. But what's interesting here, you get actually five paths that are really important actually. Data is where the data goes. Configuration, these are all the data pointers. This will be your, it's all actually YAML based, so they'll point to the different actually paths of data that you have for whatever versions that you have. And then source is where all the code is, and they'll be broken into pipelines and nodes. And docs are what you create, so this makes you really attentive to creating proper doc strings, like code with documentation. This will help you. So this will make you write more documentation, and maybe also write better code. Because you have some logs are good to look at to see what's been going on. Your errors and things will be there. This is how it looks actually. Notebooks. I've banned this in my organization because I don't see one of our notebooks in the commit code. They can actually do it on their own. That's great, and they can share things. But I don't want notebooks. It gets hard to a collaboration when we have to run together, merging just makes it hard. Great concept, just for execution. But anyhow, this is how it looks. No, it's actually, it is created, the one that is created is to, it shows all the ignore. These are all the things that, it actually creates this. Kedro does this new. When you do it, it knows what you're going to be doing, so you can add your things. But I tend to be very a pedestrian in my usage of this, so it just works well. So one of the core things to Kedro is making you think about your data and how you organize accessing it. And the catalog is, I think, one of the basic concepts. If all you don't get out of this is any more than the catalog is cool, then I'll have won. But keeping track of your data, even though it sounds easy, when you have 3 or 4 projects that are going on at the same time, you have people working at different rates, junior people and senior people, and it's like it gets really hard to understand where people are in things. And so getting an organization around your data and the usage of that is very, very important. And so in the catalog, which is basically in the conf base, everything is in base actually. That's not why. Catalog file is just a YAML file, and you can have all kinds of things in here. For this example, we have a temperature database. We never write out any small amount of light. I don't know why I did that here, but that's actually wrong. But anyhow, you have a type, and this CSV file, and then the file path. And this is all relative to the tree that you ran actually. And so if you go up over here, parallel to conf is actually data. And so under data is a whole bunch of things. You've probably seen it from cookie cutter, 0.1, 0.2, 0.3, and there's raw, process, and it's good to keep those names. I think it's good to think about things in terms of what stage you're at. And so this goes, by the way, on the site, I don't know who's in here is working on this actively right now, but on the site that I had linked actually, there's a couple YAML files that have this already typed up. So you just copy and paste if you want. And also there's other things that go into this. This right here isn't just your input. So this is all, other things you add to the catalog are your output, like your intermediate points. Like if you want to save your test files that you actually create on the way, most things are basically kept in memory. And this actually allows you to say, if you put things in here, you can have different ways of writing the names. So if you change basic date, you ran it, all kinds of things. But that basically allows you to have snapshots of the data that you have ran. And just for a validation step, you can always write, Kedro has a whole bunch of commands for once you've activated your environment and everything. You can easily see the things in the catalog that are underneath of the tree. You can dump these out. And like in mine, the final one, Kedro. So this is actually kind of along the way, but we had the temperature database here, and there's other things, prediction, those are all intermediate things that I've actually already defined. They look like, so this is kind of like the first part here. On the slide. And then if I want to have intermediate points, this is all. This is what we do basically. I define those, and then you can actually have those hooks so they easily leave off things. And this here is the output. These are derived from the database. And there's a whole bunch of extensible pieces that you can actually, and there's a whole page of different types that you can actually see about map out with images, PDF formats, and other things, SVG. Anything that you want to write code for, you can do it because it's pretty easy. Yeah. Yeah. Yeah, so the cookie cutter is, I haven't used it for ages, but it was basically, I started out and you give it a name and then it just would do kind of like what this actually does, but it doesn't have any of the code around it. It basically says, here's your data, your input, your output, and all the different stages of the ML processing that you would go do manually. And so it kind of addressed the points, or a couple points I had in terms of consistency. Early on, I talked about being able to come in and know where things are. That's kind of what it actually, I started out, to actually do. There's a whole bunch of code around it. We'll get to it a little bit here. But what happens is it allows you to create these nodes and pipelines, and the nodes are the processing actions that happen on the data that you've defined that you would be in the cookie cutter tree, right, where you might have some input and some output. And then the pipeline is how you want to go through the operations. You want to first do this, then this, then actually build the model, then you save it here, and so on. Yeah. Yep. Yeah. 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 I'm not sure about that actually file. Yeah, I see project here. Yeah. Yep. This is where the action name is defined that you put in there. I never used this other than the actual name. If you change the name, that's where you would change that and the versioning of the actual project. But I've not used. Okay. Um, so we have the catalog defined with that actually one entry, right? And it points to the CSV file. You can also run the Kedro pipeline and kind of dig in if you want to. There's a way to look through the catalog as the first class object that you can actually get into and access, and then do a load. Now we're just bringing up the actual data frame that was actually loaded. This is mainly for just toying around. I don't use as much, but it's like if you have some extra problems, it's kind of nice to be able to have an access. So now getting into pipelines. This is not necessarily cookie cutter type of things, but it's good to name things the same way. Like every project I always have a data engineering and a data science pipeline. These other ones I maybe do not use. Like within this example, I only have data engineering and data science. But it's good to have the same names. And yeah, just pick it, a convention, and actually stick with it. So first thing you would basically do, and this is to create the first line of action, which would be the data engineering piece. And it's Kedro pipeline create data engineering. This is, of course, where you can call it anything, but make sure you just stick with something that makes sense, right? Don't call things DE, because that's a country, and it does make a lot of sense to other people want it a little bit easier to see. So once you actually run this, you'll see it successfully created, and then so that's the first node pipeline, and then the data science piece is the next one. And so both those two together, you should be able to see inside of the pipelines. You should be able to see inside the source, idea 2022. Pipelines will have two subjects. Okay. And I say you should see three vectors. Actually, it should be two, because I did have another part to this, but it went too long. I was like, I gotta cut this down. All right, so now here's where we actually get some work done. This is, I have a file here. Okay, good. Okay, so I have a supporting file on GitHub, and also locally here I can show you. But so there's the data engineering aspect. We're going to basically take what we defined in the catalog, and we're going to all we do is going to split it into testing and training. Just so simple. Actually, this whole example can probably be done in 30 lines of code. So, but it's if you grow into a large project, it would still basically the same. Just you have much more actions going on in the code. But so the nodes in the data engineering path, this is going to be where all the action happens on data coming in and data coming out. The pipeline is going to define all those actual functions as nodes, so that you can actually then organize them in some other way. Okay? And once you have defined code, and I'll show you how it looks actually. So for this is basically right there. You have nothing more than the train test split. Split data is actually defined, input, and I have two things coming out. That's all it is. And so that's my data work there. And then you could take this and actually just run that node by itself. Okay. But only after you defined the pipeline, which is right. So this is the pipeline code. And so remember, node is the actual code that does the work, and the pipeline is how you hook it up. Okay. And so this, if you have more than a single function, you would have more nodes defined. But the function itself, the inputs, this represents the pointer to the catalog. And then the outputs are train data and test data. And then the name of this node is node train test split. You can name this where you want it to, but it's good to have a convention. I'm trying to get that actually as being. That's like it's all about conventions. It's not really enforced, but you won't figure out where the node is called. Like node underscore obviously is node. Right? So once you have defined that, then you can easily then turn around and execute just that node, which will then execute the, you would have to be able to execute this pipeline. Find out what that means. Everyone fine? Okay. So I'm going to show you how it looks actually. This might be a little bit too much, but I have actually defined. So this is actually with both data engineering and data science pipeline is done. Pointer here, but the function at the top is what we just actually defined, which is the data split method. And then you have the training and testing. Training goes into our training the actual EU model. Output is the predictions. And then this one here is actually, that's the prediction. Yeah. And so this is basically the prediction thing. And what the yellow is I was going to talk about this. You can add a lot of parameters to these actually nodes, and these functions. I don't know if you can see this. Well, so you can actually pull out things and these actually values that you want to pass in, and be able to keep track of all those parameters. This actually, like the contamination factor, is in a file that is actually in the conf base parameters.yaml is contamination factor right there. And so if you have any things you want to keep in terms of the project going through, and these are the things that you would actually tweak. Then this is where you would put them at. Instead of putting them into code, right, you would put them in here, and then in the implementation factor in the training of the model there, and then in the data science pipeline, that looks like this actually. You put this in param in the node, when you define the node, that gets pulled in from the actual YAML file. So instead of passing things around in functional form, you put it in here and they'll be kept in the parameters YAML file. Yeah. Yep. We'll go through that right now. Yeah. We'll talk about that right now. So I kind of talked about this already. This right here part. This is the data science part that you went ahead and already did. Yeah. Yeah. I'll get to that. And so this is on the parameters. The implementation factor would go into the const-based parameters.yaml file as implementation factor colon some value small, less than 1 or so. And to answer your question about bringing this all together, you need to, these individual pipelines make sense by themselves, and they should be able to be ran independently. But what you want to do, and what I was showing from the web user interface there, shows everything all together, and that is done by basically the pipeline registry, which is actually above those other two pipelines. Yeah. This and this is how it looks right there. Conf-based parameters. I always err on adding things here because if you hardcode things, which is always kind of fun and easy, but it's easier to do this up front if you know what you're going to be tuning. Usually, if you've done things before, right, you know certain models need certain parameter points to tweak, and so I would add them here. So then, registering the pipeline, which looks like this actually. Basically, you break things in, those two mesh pipelines, NGS here, and then basically creating those pipelines individually, and then it returns a dictionary of basically, I'm going to run this one, the NGS, what's the default, and basically these two things add together. And all this is actually is of actual graph. Just an actual DAG of nodes that it walks to create the trees, to execute, and also to actually show how things look in this form. It is somehow hard to see. Yeah. Everyone loves YAML until you have to use it. And you're like, oh, you came up with this stuff. Yeah, that's how it should look right there. Yeah. Let me know if that doesn't help. But, and so then this is actually the pipeline. And to be honest, this is not the most useful thing. You can't do much with this other than show it off to managers, which actually does help. But I guess it's a good thing to have to be able to pull up what a project did and be able to point out that this is where I did a bunch of code that was like this, because the hardest part of ML projects is that you end up doing things over and over again. And if you think about things well enough in terms of getting this into a structure, that makes sense once, you'll probably end up doing it again, which is where a lot of the actual value here is. And then I'm going to show this. Is yours working fine now? Okay, I'll help you there. Kedro run basically runs through everything, and it logs things to the log file. And so I love the actual warnings here. There's nice to see. Just Feudal's having its versions of being done and so on. But we have basically the logs. We have loading this up from this. It's actually running this node. It's splitting data. Here's where it goes. It's saving data here. These were implicitly actually defined, like I said before, in the catalog, right? You add things to the catalog, they get matched, and then they basically get saved off. And when you're running training, you can save off the model too. And this is where I would use ML flow to actually version the actual models that you make. And then when it's done with the running, the model, this is all in memory. And then prediction here, test data is being saved, and then that goes out to the output. So then basically I have a whole trip from input to output. Okay? And so you can also just run a subset of what we just did. So if you only want to run the data engineering side of things to, say, clean data or something, you can just actually run that. And it's not the easiest to do that, because that's kind of how you can get into using it as a tool that you've already done. You get a very complicated chain of processing. You could use that chain on other things, other data sets. You need to define them in the catalog. And so now, next you could do is Kedro package, which would package everything you had up and then make it into something you could install with pip. I have done a little bit of this, and it's really interesting. It is kind of, there's not an easy way to basically put this out there, but it is, your work's done in a sense that you package it up so that it's easy for someone like a DevOps person to actually handle this, and you could actually walk them through it, how to use it. Also, there's a bunch of other things like building docs, which is good to have around, and you can make sure that you write doc strings in their code. And so, overall, we've actually attacked some of the problems. This is not going to solve all the MLOps issues, but the biggest thing that I need is actually reproducibility. Can I take something and rebuild it 6 months from now? Can I build something and then actually take pieces of that and use it in other actual projects? So modularity. I think a lot of that comes from actually just thinking about things, right? When you're breaking out the actual problem, when you're doing the data engineering side of things, how do you process that? Maintaining the ability. Obviously, you have to do this stuff for an actual job, so you need to have people where they're not going to be around for a while. You need to be able to actually plan for that. Hopefully, you have a nice company that makes people happy, so they actually want to stay. But that's not always the case, and so it's kind of nice to have a project that you can actually get into and know where things are. And again, versioning. So versioning is not explicit here, though. it's in the catalog, and so this actually does address what data was used to build Model X. It doesn't say that's version 1.0 of the file, whatever. And so the versioning is more of an implied thing, but I think knowing which data was used is all I need. If you want to have version 1.2 of this, then there's the cookie cutter actually paths where you would have intermediate steps, is where you would define catalog entries for intermediate data processing steps that you want to have artifacts held around for. Documentation and packaging, these are kind of light, but it is something that you get. You can easily doc strings out yourself, but it's kind of harder in the ML sense to have everything making sense. So the docs are good. And packaging does help. There's lots of ways. If you look on the Kedro site, there's a lot of different ways you can basically plug this into other things and have it work. And so if you want to use Kedro, by the way, this was a forcing function for me to actually do some of the work I've been doing. And so it was kind of, I've been wanting to get into this, and I use this as I have to give a talk on this. So I have to actually, I actually had to kind of come to grips with, I need to make my ML stuff not be like how I've done it before in the past. And so I need to be able to actually grow the group and so on. And I need to have everyone coming in, knowing what's going on. And so this is kind of me kind of bringing in, what am I going to do? And so I converted a project that I did to this, and it worked out great. Almost as complicated as this, but it had a lot more code in the nodes, of course. But it was pretty good. And so so when I hire other people and do other things, I want to do the same type of thing and just keep on doing that, so that I can kind of know where we are, and because we actually do ship things that are going to be on vehicles that are hopefully going to keep people safe and so on. And so I need to be able to actually take those those models and maintain them for years to come, because those actually contracts are going to be there for years to come. So it's very fun. And but anyhow, I think the hardest part is just basically picking something and starting it, and then sticking with it. Don't quit. Or don't find other things that are shiny and go, oh, that looks nice, and start over there. And so, yeah, I think we talked about this already. But it's a pretty good actual framework. It's not best everything. There's a lot of issues you'll find that are kind of, it's actually, boilerplate stuff you have to actually deal with, but it's still, once you get actually used to it, it's pretty handy. And then some resources. This talk will be on the GitHub site, along with all of the data, and this is in actually Markdown. So I'll have the PDF, and this will be there. No, this is the actual PDF, and the Markdown will be there. And then these are the links, so things, MLOps site, which has all the pretty pictures of how things look in at big companies. The Kedro GitHub and Docs, and also it's nice if you want to do actual model, do actual versioning. You might want to use Neptune to do things, which is Neptune.ai, which is a cloud service for people that can access clouds. I can't do that stuff, but it's kind of nice to be able to put in your code certain points to be able to basically know what you hit in your operating path. It makes nice charts and things. You can actually figure out what's going on. And then again, if you don't want to do the whole pill of actually, you can take the cutter as a half dose, I guess, and try to shoehorn a lot of these things into that. But that's it. Did you get everything working? Good. Any questions? Yeah, far away. Mm-hmm. Yeah. Yeah, I would. Yeah. So I would. I haven't dealt with this yet to the problem, but my problems are very much the same, but also at the same time, I'm probably approaching them actually differently. So I will have some shared code. So I would probably stick with having its own thing. Each project has its own thing until you get to a point where you have a lot of shared things. If you can have a shared pipeline, then there's a way to do Kedro export, I think, pipelines. You can actually export things. I kind of like independent things, mainly because I think that a lot of times I work on problems that are, like, they'll change a lot. Like I'm working on one aircraft now that is a very different thing than the other ones that I've done. And so it looks, very different. And I'm going to solve it with a different way. And so I'm going to have a lot of code that's totally new. And so that doesn't answer your question so much, but mm-hmm. Yeah. 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 And it doesn't, it kind of makes it bad in a sense too, because you could have a point where you have code that looks the same running in two different places. And then you update one, and then you have to go update the other, and then you have the whole entire mess that we've tried to solve, right? I think then I would probably reorganize it to be one project if it had a lot of shared functionality. But I would grow with it for a while and try to figure out if it works. And those kind of things would be interesting, because there are some people that have talked about it online, how to do that kind of stuff. And yeah. Yeah. I think the biggest part is that it makes me more aware of structure and testing of things, so that I do have a lot of, we have these thing called, it's called a hill. It's hardware in the loop. And basically all of, like, we have this tank that basically is all the pieces that are of the tank, all the driving pieces, but not the actual tank itself. And so you can actually put the hardware, the software there, and actually do a lot of testing. So this kind of makes it easier to test even more often. I think any other way I would do it, I'd probably do the same thing. It's a cron job. It runs whenever it can. You have CI, CD stuff that does things over there, and I think the biggest part is that you have testing is kind of a little bit actually easier, and you can hand it off to someone else, and they'll know how to actually test it if they're on your team. I think that's about it. I think. Yeah. Mm-hmm. Yeah. So this can plug into Airflow. What you want to do? There's things you can do with it. I needed to have an open source answer to things. I wanted to have code that I could actually take off. And we have to submit when we go to the FAA and have our stuff has to be like, here's all the code that runs on this stuff, and we need to have it as open and transparent as possible, because it gets us being signed off on things a little easier. And it's a closed source answer, a little harder to get it signed off on, and have to usually, those people need to then be also certified. And so, yeah.
Any standard practice would give it more for this, or don't just push what people.
This actually creates some get ignore all the things that are contained.
Okay.
And I just use that.
Okay.
I do. I'm working on some Go stuff, and I added some things to Go, but that's what talking to this problem. Really. Yeah.
So, like, most of the stuff you reference data sets, or you reference models. So all the artifacts
So everything is in this tree down.
Yeah.
So all the catalog references the data tree.
Yes.
And so that, as long as if you find it in the catalog, it will, when you run the tree again, it will actually create the models if you want to. They'll be there, and so they'll be kept there. There are ways to in the catalog of giving things names and names name specifiers, like you can change the name so that it has a date always. So you have 20 of them if you do that for every day you ran. You actually ran them.
But one is one of your coworkers, one is like hopefully one of your common coworkers, would love to take down, love to run your pipeline. How do they access both the artifact and the model and all the data?
Yeah, so that is where you have a common server. I like to have people that I do work now. I want them to run the code on their own thing, and usually I have a script that brings everything up actually, so that it installs actually does a PyM that you create and does a pip install and then runs everything, so that basically it's all what is actually checked in should work and create the same thing that I have.
Yeah, I imagine you could put the entire thing into like a Docker file, right?
Mhm.
Like you
Yeah.
have this as an image.
This is kind of a follow-up question for Kedro versus other frameworks. And when I think about Django versus Flask, Kedro looks more like Django. It's a big framework. It's kind of opinionated. It introduces structure.
Mhm.
But the downside is it's going to be hard to migrate. And sometimes it does not support the advanced use cases. So my question is, have you encountered backend problems and
I haven't moved where anywhere yet, so I'm going to be seeing this for a bit. That said, I think it's opinionated and it's that structure, but the data is there. And I think the hardest part is if you do anything else, you have to copy out the code from the nodes and put it into something that looks like the pipeline that you actually defined. That's not that complicated, I think, but if you ever want to move out, it wouldn't be that hard. But I don't know what you would move to, because the things that I've seen out there, like there's MLOps, does some things, but it's very, very lightweight to what this does. Yeah. But hopefully, I used to, when I was younger, I used to move around a lot. And, this is shiny, and now I'm like, no, I'm done with that. I'm gonna keep doing this right here because it works, and I do a great thing. But now I have, we have, customers that need to have things that work, and I need to make sure that the problem that I'm solving is actually working more than different work.
And have you tried bringing in MLOps?
I have, yes.
Yeah.
I-
Where does that come in? I know that you
It
mentioned
is,
operation.
there's a package on GitHub that's called Kedro -MLOps.
Okay.
It kind of brings them together, and it's basically at the end that had the step to basically register modeling and it will keep actually different versions. I'm using SQLite locally,
Okay.
so it's keeping versions in there, and I don't want to have an external server to the things I have right now, but it does make it a little hard for, I think, disaster recovery would probably hate me for doing all that stuff. It's like, oh, yeah, it's in a database log.
Kind of curious about the unit testing or the integration testing process here. So we just supposed to use just PyData so that you find the testing data binary, maybe do hypotheses and stuff generate a pseudo test behaviors, or is it possible to kind of actually take the rows from the actual data set and test it?
Yeah, so I've done both PyTest is fine. I think that's really good for little things, but system level things, I would define actually an actual pipeline to do things.
Okay.
And so you can actually reference the nodes that you already wrote.
Right.
You can actually just reference those and say, I want to pull in this node to load a file and then transform it. and I want to run it through this, you know, you can do that. I mean, just, I think it's really good to get into the mindset of writing your nodes independent of Kedro.
Right.
Like, there shouldn't be any Kedro stuff in there.
Right.
So you're just taking data in, you're doing something, and
Yeah,
something out.
yeah.
And so I think that if you do that, your test becomes pretty easy to do.
Right.
And also, reusability is like when you've already functions like this before, right? Like you do this and do it again and again and again. It's like the same thing happens. So you end up being able to pull things out really easily. Yeah.
Chris, did you see the Zero data science talk on Tuesday?
Yep.
Yeah, I was curious if you had thoughts on that talk.
Yeah, when he said it's really hard, you never get down to the end of a you know, tutorial session. I'm like, oh crap, I'm doing one on this, and so I did take out the extra pipeline because of that. I was like, oh, I need to get this down a little bit, but I think he had a lot of good points. He wasn't, I think, he didn't know the cookie cutter was used in Kedro, and he actually talked about doing the talk.
Yeah, that's what I was interested in.
Yeah.
He specifically said Kedro, but this would be opted in. So I was like,
Yeah.
curious how you felt
Yeah.
about that.
This is easy install.
Yeah, I think I've not yet tried it out.
Easy
So I have
Easy
not
install?
done it. Easy install, I believe.
Yeah. But I use that. And I'm not going to change anything. I'm like, hanging the course right now.
I mean, speaking of the drawing environment, it seems like, I think my concern is more teaching people who are becoming fresh on how to get started doing work and providing some sort of defined structure for that. And I also feel like, at least in my work, I don't think nobody's going to give up their notebooks. Like, probably not with their cold in hands. Probably.
Well, I think there's a point when people, I think that the notebooks are nice and they're nice to kind of interact with others and go through ideas. But when you want to ship code, it's just that there's no place for that. I mean, like it has to be. Like I have to give actual models to the team, and they need to convert to something else, right? And so it's like it gets really hard when you know you have to have code that no one outside other group I'm in would know what an actual notebook is, other than a bunch of paper, right? They wouldn't know what it is. And so I think there's nice time for people to grow up and move out your code, move out of notebooks and then work over here, and it's good. It's a good thing to keep though. But yeah, I just don't want people working on my team actively committing things in notebooks on shared work.
Oh,
Because just like it's people have I do this and try to implement it in the notebook form, it's not gonna work.
I guess the things I know Netflix did a thing called paper mill for like running notebooks for CLI. I think because they couldn't get people to give out their notebooks.
Kedro does support it, you just toss in your stuff and it works. And I'm like, I just kind of back away from that really, really slowly. Like, just like, okay. Yeah. Anything else? Yeah.
How would you compare this to MLOps Do project? Because like you mentioned MLOps tracking or other things, so I think the project is trying to do something similar.
Yeah, I haven't used it. That's the easy answer. But there are pieces of it of actually MLOps that I think are also good. The registry part is really good, I think. But like I was saying before, just like pick one and stick with it. I think they both have their ways of doing things, and they do make a lot of assumptions. But I think once you do get into it, it's good to kind of be able to work with it. But yeah, I haven't actually dealt with it, and I probably won't.
Yes. Have you thought about like data versioning, and have you ever tried any tools? Because there's so many MLOps tools out there, but I don't think there are not so many tools about like data versioning, and but machine learning always comes down to data.
Yeah.
So it's kind of
Yeah, I'm still old school on that. And I usually have data that I have a name in the file, like where it came from, and it's like and then from there I version things, and so I know where it actually came from. But then once it gets into my hands, I go through and I version it by basically creating
points, like if I have a training test set, I would keep that around. So I go back and easily, know what I should train on. But I don't do any automatic data version. I think that'd be I'd be a little bit actually nervous. Automatically a version. I think if you do keep it in your Git, there's some data governance issues there, can be hard, but then you can at least, if it's a text file, you can easily see if the things have changed or when they changed, right? But that gets hard if you have classified stuff.
Yeah, I think that's a good point because it depends on the type of data. Have you ever had any reproducibility issue of data?
Myself? Yeah. That's why I'm so into this, because it's like being able to, you go through a whole bunch of stuff, right? And you finally have a model that works. And then you're like, how did you get to that point?
Yeah.
And then you have to trace back. You're looking at notebooks and you're like, oh heck, I don't have that now. I don't know what happened to this one point. How do I get to that point? It's actually not easy. So yeah, this is why I think having a framework around you to help you. Because as you get older, somehow you forget things. I don't know what it is. I blame the kids.
Guardrails, that's the word. Guardrails.
I think there's a guy mistake
Yes, I was
yeah, that's not very simple. Like we're gonna it's definitely like no
Yeah, that's right. This is what I'm not that.
Oh, is that?
Git LFS?
Oh yeah.
Yeah, that's similar. When you Git LFS, like you check the files in to just like a backend store, so the Git file store is running to other non-Git file store, and then you check in that hash. And then it's just saying, okay, the hash is increased, which the backend is then GitHub will heavily charge you for the more Git, backend, the more backend that you want to use.
But like, kind of like data planners, digging in the entire version, right way now, I'm trying I just gotta try to see if there's a difference. I'm trying to visualize where there's a difference. So like you have create a hash for each column and stuff.
Oh, okay, yeah.
it was really good. So the merges work properly. As long as you've got good indexes on your data, it actually is. It's brilliant. It just looks like these actual column entries change.
Yeah.
And they have their own thing called Dogtool. And I did mention there was some integration between GitHub and Dogtool.
Yeah.
So that you could maybe store your schemas in
Yeah.
GitHub and the data in Dogtool.
Yeah, and like ideally, like if all the data, like if all the column source tables are like defined like all not all the like most of the data, so but like in reality it's not. So like if you have just the individual tables, but like if the the original table changes, that has happened multiple times. So traumatized by that.
So Brian, do we really need all the things?
No.
Oh.
Yeah, it's interesting because you read the MLOps papers at bigger conferences, like they have all these feature stores and it's like there's so many things, and I know there's a lot of companies that make money on this, and a lot of them make sense for certain size of problem. But I mean, I have petabytes of data, but I'm not processing it right now or in a week. It's like it's over periods of time that are on the order of years, and I'm not actively having to take all those hits or whatever right now. And so all those feature stores and things, I don't need that stuff. And the model registry is like, well, we need to have that, but it's like I think you can actually manage that locally. Yeah, but you don't have to do so much, so much overhead. And hiring people and all these things to do this, like it's really actually much. My side's work on an embedded device that isn't real time, but it's pretty lightweight. It can't be too big. So I don't have a big, huge actual problem like some ML models are.
I'm just curious, and if you can tell, like, what is the deployment process like model deployment process like in the, I guess, defense industry? Because I'm kind of wondering, like, if it's like,
Yeah, it's first off, you start with lots of paperwork, lots of acronyms like ATO to operate. And they all these things, and it takes months.
Right.
Months. It's pretty well. Everything that's involved in a project has to be. You have to know how it was done, and it would have checks everywhere. It's a mess.
yeah.
Luckily, I don't do that though too much.
Yeah, we have seen that process.
Yeah.
We cannot just test the model on patients, right?
Yeah. Yeah. Yeah.
We go trial and so on.
I think that defense is probably harder than previous hospitals, though. I think that I've seen both sides of things. And I would say that the defense is a lot more money in it. So I don't know. Seems like there's a lot.
Good point.
Yeah. There's also, I mean, like, when you get things certified for actually being a commercial aircraft, it takes literally years to get a box to be certified flying in a 737, which is good. I think you want that, but it is a lot of actually work to get it in there the first time.
So like you have to go through a bunch of trainings, it's like, I'm also like have to get shit like on the like a payer side, but still like I have to take like PHI, like a PII training every 3 months, and then like security training every 3 months and stuff.
Yeah. And if you ever pray when you fly, pray when you land, not when you take off. It's only when you land.
It's ominous.
Makes sense.
Thank you all.
Yeah.